Yep, so hi everyone, I'm Alex Turner. I'm a research fellow at the Manchester Centre for Health Economics at the University of Manchester. So today I'm going to talk about part of my project from my PhD. I'm going to aim to give you a brief introduction to what I hope is an interesting topic for you. But given the theme of the kind of conference, I'm going to focus it more on methods, in particular how to estimate causal effects, or the true effects of in-utero exposure to influenza on their later life outcomes. So what does in-utero exposure to influenza mean? So this is exposure to influenza whilst your mother is pregnant with you. So we want to look at being exposed to influenza and the effects that has on their offspring's outcomes throughout their life course. So there's a bit more of a brief introduction to the topic. So many of you will observe a huge variation in important outcomes across individuals. So you might observe that one individual is more healthy than another, they have better cognitive skills, also non-cognitive skills, such as greater self-esteem, more sociability. Some individuals achieve a higher level of education, and that means that they achieve a higher wage rate. The point of research is to determine why is there such variation in outcomes. What is it that determines these observed differences across individuals? So during the past decade, there's been a move of research to examine whether the circumstances which occur early in an individual's life may have a role to play in determining these outcomes. So a couple of examples here. Researchers found that those growing up in more affluent families, measured by parental education, parental employment and parental income, go on to have higher levels of health both in childhood and adulthood. In addition, those in better health in childhood go on to achieve higher levels of education and also obtain a higher wage rate in the labour market. However, over the past couple of years, particular focus has been switched to conditions in utero and what impact that might have in later life. These are conditions which are faced by fetuses when in the womb prior to birth. So much of this research has focused on the effects of maternal health behaviours, such as smoking and drinking during pregnancy. A range of studies have found effects on a range of negative outcomes throughout the life course, and a lot of this has received quite a lot of attention in the news. So these studies, for example, have established impacts of smoking and drinking during pregnancy on childhood brain damage, and also increasing the risk of behavioural problems during childhood. But less is known about the effects of mother's health during pregnancy and what impact that might have on their offspring. So we focus on influenza, which is a common disease which affects between 5 and 15% of the population every year. And due to changes in the immune system and the functioning of the heart and lungs during pregnancy, it means that pregnant women are more prone to severe illness and maternal death as a result of contracting flu compared to the general population. There's also been some evidence of effects on the fetus, with exposure leading to increased probabilities of premature births, low birth weight births, and also stillbirths. However, less is known about the later life effects of being exposed to influenza in the womb. So here I'm going to focus on two examples. One, studying the effects of flu exposure on cognitive ability in childhood, and also we add to the evidence base studying the effects of exposure on the rate of stillbirths as well. So before I go into the methods, I'm just going to explain the mechanisms through which we think exposure will impact our outcomes. So begin with cognitive ability. Many of the mechanisms relate to brain development. So the development of the brain primarily occurs between 8 and 25 weeks into gestation. That's 8 and 25 weeks into pregnancy. And during this developmental period, the human brain is more susceptible to shocks to health. And in-utero exposure to influenza can lead to many of these health insults. So one example is undernutrition. So influenza acts to suppress appetite, leading to substantially reduced nutritional intake. Also, contracting influenza may increase maternal psychosocial stress, which also disrupts fetal growth. Mechanisms impacting stillbirth rate is a little less well understood, but research has shown that fetal death may be related to fetal brain damage, which links to the mechanism above, but also an inflammatory response by the mother, which may lead to stillbirth. So now, importantly, how do we test for these effects? How do we test the effects of in-utero exposure to influenza? So what economists are interested in is what we term the causal effect. So this is a true effect of in-utero exposure to influenza on these outcomes. So it's not just correlations, it's what is the actual effect of being exposed. So I'm going to go through three methods here, which kind of increase in their degree of complication. So we're going to begin with simple ordinary least squares OLS regression, which many of you will be aware of. And I'll discuss some of the reasons why this might not lead to an estimation of causal effects. Then we'll move on to randomized experiments and then natural experiments. So these are naturally occurring reasons why some mothers contract influenza more than others. And I'll take you through two methods, one based on whether you've got individual level data on influenza exposure, and another which can be implemented when you don't have such data. So move on to the most simple approach, which is the simple OLS regression. So what you do here is you simply run a regression where the outcome is your child outcome of interest, which we term YI here. And you regress that outcome on a binary indicator for whether an individual was exposed to influenza in utero, which is the flu I indicator here. You might also want to include a range of child and family background characteristics which you think are correlated with both flu exposure and your outcome. And importantly, UI here is the error term, and this contains all other determinants of your outcome which are unobserved and therefore you can't include explicitly in your model. So what we're interested in here is the beta term, and this the estimate of beta is the estimated effect of in utero exposure to influenza on cognitive ability or stillbirth rate in childhood. So what we've got to ask ourselves as researchers is, does this beta term represent the causal effect? Does it represent the true effect of in utero exposure to influenza? So causality requires an assumption that the error term U is uncorrelated with flu exposure. So is this likely to hold? Well, a lot of these regressions are run using observational data sets, and these can be quite limited in what data they collect. So it's unlikely that all child and family background characteristics that you think are correlated with the outcome could be included in there, and you might not be able to control for it. If these unobservables are also correlated with flu exposure, then this causality assumption that the error term is uncorrelated with flu won't hold. Therefore, we say that beta suffers from omitted variable bias, and beta does not represent the true causal effect. So, given that OLS may not lead to estimation of a causal effect, what methods can we employ? So first of all, what's used widely in health economics and in other areas, for example, to assess the efficacy of drugs or new health interventions, is randomized experiments or randomized controlled trials. So in this setting, you take a sample of pregnant women and you randomize some group of women to contract influenza, this would be the treatment group, and another group to not contract influenza, which would be the control group. So as a result of randomization, the two groups should be identical apart from flu exposure. So by construction, influenza during pregnancy and therefore in utero exposure to influenza of their offspring would be in correlate with all possible family and background characteristics. And the causal effect could simply be obtained by comparing the outcomes of the treatment group and the control group. But there's a massive problem with this. It's impossible to conduct a randomized experiment in this setting. One, it's unethical for women in the control group to be locked up in some form of sterilised room so that they can't contract influenza. And also, it's unethical to give all women in the treatment group influenza, given the effects that it has and the increased risks of maternal death from doing that. So given this, we can't do this, so what can we do? So economists usually rely on natural experiments. So these are naturally occurring reasons why some pregnant women contract influenza and others do not. So this is random variations in the probability of contracting influenza. So what natural experiments are available in relation to influenza? And the majority of the previous literature has relied on data from Influenza Pandemics. So these are usually when a new strain of influenza is introduced into the human population, usually from a non-human host, such as birds, and they tend to spread rapidly throughout the population, covering most of a particular country or across continents, and lead to very high infection rates. And there's been 3 such pandemics in the 20th century. Firstly is the 1918 Spanish flu, which actually killed more individuals in the US than World War I. Secondly, the 1957 Asian flu, and lastly in 1968-69, which was the Hong Kong flu. So unlike seasonal influenza outbreaks, which occur every year, these kind of tend to infect the elderly and those under age 2 primarily. Influenza cases which occur during pandemics are usually indiscriminate. So what we mean, it infects everybody. It infects high social classes, low social classes, the old, the young, middle-aged. So given this, it can be argued that cases of influenza occurring during a pandemic are as good as randomly assigned. So it's randomly assigned who gets influenza and who doesn't, just like occurs in a randomized experiment. The The severity of the epidemics also tend to vary randomly by geographical location, so there's random variation across regions of, say, the UK. So in this presentation, I'm going to show you some examples of how geographical variation in epidemic severity can be used to identify the causal effects of in-utero exposure to influenza. So as I said before, there's two cases. One is where individual level data on flu exposure is available, and another case where no individual level data on influenza is available. So I'm going to explain two cases with examples, but first I'm going to begin with the case where there's no individual level data. And this is commonplace in previous studies because long-term follow-up of individuals with data on whether they were exposed to flu in utero is notoriously hard to come by. So this is what previous research has focused on. And again, to test causal effects, it's again quite a simple regression. So instead of regressing your outcome, your child outcome of interest, on the binary variable for whether you were exposed to flu at an individual level, you replace that with a measure of epidemic severity at some geographical level. So, and it would be, EpidSevG here represents the severity of an epidemic in the geographical location where that individual was in utero, where the location where your mother was pregnant with you. So we use this as a proxy for whether an individual was exposed to influenza at an individual level. So under the assumption that the higher the level of epidemic severity in any given geographical location, the larger the probability that any pregnant mother within that region would contract influenza. You might also want to include a range of characteristics which you think might be correlated with disease spread. So this might be population density, the number of school children in a particular area, or the number of persons per room within a household, which might determine pandemic spread. After controlling for this, then we assume that epidemic severity is as good as randomly assigned. Like I explained previously, it's random what area of a country is exposed to a high level of severity. Given it's randomly assigned, it should be uncorrelated with any unobserved determinants of the outcome in the error term U. So given this, we're meeting the assumption needed for causality. So beta here would represent the causal effect of epidemic severity on the child outcome of interest. So to go through an example of this, we take a very good paper written by Elaine Kelly, published in 2011. And as you can imagine, the data requirements here are pretty strong. So you require data on an epidemic which occurs a long time in the past, and you also require a data set which covers individuals born in that period and follows them throughout time. And this is one of the rare examples where these data requirements are met. So she uses local authority level data on the severity of the 1957 Asian flu epidemic across 172 local authorities of the UK. And she proxies epidemic severity using the number of pneumonia cases per 100,000 of the population. So this is by no means a perfect proxy because you'd prefer influenza cases per 100,000 population. But unfortunately, in 1957, the number of influenza cases wasn't reported to general practitioners, so it wasn't available in this time period. So we use pneumonia cases under the assumption that 1 in every 417 influenza cases result in a pneumonia case. And she also uses data from the National Child Development Study, or the NCDS. So this is a birth cohort data set which has followed a group of approximately 17,000 British individuals born in the first week of March 1958, and it's followed them from birth up until present day and collected data on these individuals at a range of points throughout their life course. Importantly for this study is that the NCDS cohort were between 8 and 25 weeks into gestation, so their mothers were between 8 and 25 weeks into pregnancy in the main epidemic period. So all of these individuals in this data set were exposed to this epidemic. And also she focuses on cognitive ability in childhood, and this is measured in this data set at ages 7 and 11. So what regression does she run? So she simply regresses cognitive ability at age 7 and 11 on this measure of epidemic severity at the local authority level, the number of pneumonia cases. And she also includes a number of area level characteristics that she thinks correlates with epidemic severity spread. Also, given that epidemic severity is as good as randomly assigned, this beta here represents the causal effect of an additional case of pneumonia per 100,000 population on cognitive ability. So applying this regression technique, what does she find? So she finds that a higher level of epidemic severity in the local authority in which the individual is in utero reduces cognitive ability at both ages 7 and age 11. So they interpret this as in-utero exposure to influenza causally reducing the cognitive ability in childhood. However, with no individual level data on influenza, they can only examine the causal effect of epidemic severity on cognitive ability and not the impact of exposure to influenza at an individual level. And for this, you require individual level data on influenza. And this is what we've managed to find in our work. And to test causal effects in this setting, we use an approach called the instrumental variables approach. So it's quite a complex method, but I'm going to try and explain it quite simply here. So it involves a two-stage estimation rather than a one-stage estimation previously. So in the first stage, you want to look at how epidemic severity at the local authority level predicts individual level exposure to influenza. So you run a regression of individual level flu on epidemic severity and a range of other variables. And then from that, you can create a prediction of the probability of flu at an individual level. And these are the predicted probabilities of being exposed to influenza at an individual level as a result of being randomly situated in even a high or low epidemic severity area. So you've got some random variation in individual level flu exposure, which is not correlated with all these things that we're worried about. Then in the second stage, you regress the child outcomes on this predicted level of flu exposure rather than the observed flu exposure. And as flu only varies randomly across individuals, it's uncorrelated with the error term, and therefore we can estimate causal effects as long as these two assumptions hold. So one is that we've got a strong instrument, and what we mean by that is that epidemic severity strongly predicts individual level flu exposure. Also, we assume that there's no direct effect of the instrument on the outcome. So we assume that epidemic severity only impacts our outcome through increasing the level of in-utero exposure to influenza at an individual level. If these hold, we estimate a causal effect. So just as an example here, I'm just going to take you through an bit of work that I conducted along with my PhD supervisors. So we use the same base data as Elaine Kelly's paper. So again, we use a local authority level data on epidemic severity, and we use cohort data from the NCDS. But actually, we're able to obtain an individual level measure of flu. So mothers of the NCDS cohort were asked to complete a short survey shortly after giving birth. And in that survey, there was a question included asking mothers whether they contracted a range of conditions or a range of diseases during pregnancy. Importantly for us, one of these was influenza. So this data is a new release, and that's why it wasn't used in the previous iterations of this paper, in Elaine Kelly's paper. In our outcome, we don't look at cognitive ability. We instead look at a dummy variable for whether a cohort member was stillborn, because this is the outcome widely studied in the literature, and no one has yet determined the individual level causal effects on stillbirths. So what results do we find here? So on the left table there, we see the results of the first stage of the IV estimation. So this is the effect of epidemic severity on individual level flu exposure. And so what was surprising was that we found that epidemic severity failed to predict the probability of individual level flu exposure. So the level of severity of the epidemic at an individual level wasn't correlated with individual level flu exposure, which we found very strange, and we spent a lot of time looking into why this may be the case. And one of the reasons we came up with is that the local authority pneumonia rates, which we use to proxy epidemic severity, may not be a good proxy for the influenza rates, which should be perfectly used to proxy epidemic severity. So this has severe implications for previous studies which have used this proxy as a measure of epidemic severity, but we won't go into this here. But I don't need to go away from this thinking that IV is not a valid approach. It's not worked in this case, but it does work in a lot of settings. But we didn't want to just leave it there, so we wanted to check whether there were some results that we could glean from this, even though the IV strategy failed. So the assumption here was that an OLS regression would have generated biased effects. They wouldn't have estimated the true causal effect. So in order to test this, we wanted to look at whether flu was in fact randomly assigned, because, as I said previously, usually pandemics are indiscriminate who knew the effect. It may well be that individual level flu in this case was randomly assigned. It was uncorrelated with all these child characteristics and these family background characteristics. So when looking at this, we found that flu was uncorrelated with everything that we thought would be correlated. So there was no gender gradient, there was no social class gradient, there was no gradient based on the health of the mother in other areas. So from this, we gleaned that individual level flu was randomly assigned, and then OLS estimates may well estimate causal effects. And these OLS estimates are in the top right-hand corner here. So what we found was that being exposed to influenza in utero increased the probability of being stillborn by just under 1 percentage point. And that might not sound like a lot, but if we consider that the stillbirth rate in the non-exposed group, so these were the individuals who weren't exposed to influenza in utero, the stillbirth rate there was 1.6%, then a 1 percentage point increase in that leads to a relative risk increase of a stillbirth by 60%. So this is a huge effect. So what conclusions can we draw from this research? So is more evidence of the negative effects of influenza during pregnancy. So contracting influenza during pregnancy not only harms the mother, but we show that it has large effects for the offspring, both in terms of birth outcomes and also in outcomes throughout the life course. And this is particularly important because in the UK, it's recommended that pregnant mothers should be vaccinated against influenza in the early stages of pregnancy, and that is to protect themselves against the effects of flu. And uptake in 2015 was only 45%, which is disastrously low. And also in other countries outside the UK, there's no recommendations at all for an influenza vaccination. And this is not only like kind of poor countries, this is like Australia up until recently didn't have a recommendation for this. Given what we find that there's large effects of being exposed to influenza in utero on the offspring outcomes, then we think it's a priority to increase this percentage. So we suggest that governments should introduce recommendations in countries where they're not currently in place. And in the UK, we encourage the government to introduce policies in order to try and incentivise improvements in this uptake rate.